In this question, we have a word problem, and the first thing we want to do is try and make a picture, draw something with this. So read it over and then read it over again and try to figure out what we do. So we have a ladder leaning against the side of a building. You can picture that with its base 4 feet from the wall, and it reaches 10 feet up the wall. What is the angle of inclination of the ladder? So first of all, the angle of inclination might be a new thing, but it's just the angle. I'll show it in the picture. Um, and what would that look like? Well, you can get as fancy as you want with your diagram. I like to keep it really simple. So we have a building, and then we have a ladder leaning up against the building. Now it's 4 feet from the base of the wall and it's 9 feet up. So that means it's reaching higher up the wall than it is from the base. So this would be 9, this would be 4, and then we complete the triangle. We assume that the building is square with the ground because we have to assume that because we're working with right triangles. So again, you could draw a picture like that. You could draw it like this, right angle, 4, 9, and what are we looking for? We're looking for the angle of inclination. We're looking for this angle that goes up. So inclination means you're looking up from the horizontal. So diagrams do not have to be perfect. They don't have to be to scale. But the one thing that you should do is, with this picture, the 4 should be smaller than the 9. Now that automatically tells me that this angle is bigger than 45 degrees. This angle is less than 45. We don't need to know that angle. This is the angle that we're interested in, so it has to be bigger than 45 degrees. If you wanted, here's the same drawing from the textbook, and you can see it's a little bit prettier than mine, but the same idea. 4 feet, 9 feet. This is your ladder. Some people will draw it so it looks like a ladder. If you want to do that, go ahead. The important thing is you have a triangle that has a right angle, and this is your angle of inclination. So what do we do? Well, since we're looking for angle R, and you could label them whatever you want, we're looking for angle R, we know the opposite and we know the adjacent sides. So we're going to use tangent. And the tangent would equal opposite over adjacent, which is 9 over 4. So once you have your drawing done, once you have your triangle, you do it just like questions you've done before. To solve for R, you take the R equals tan minus 1 of 9 over 4. You could leave it as a fraction. In fact, I prefer leaving it as a fraction because if you round off your fraction, then you might end up with an error that way. Now let's take a look at what it would look like in the calculator. So again, this is the Desmos calculator, which I like to use. We want to enter this in as a fraction. I just go 9 divided by 4, and I get my answer of 66.0375. Now in the question, I asked for it to round it to the nearest tenth. So that means I'm looking at everything to the left of that. So it'd be 66.0 or 66.1. I have to look at the 3 to decide whether I round up or round down. And I'm going to be rounding down to the 0.0. So it'll be 66.0 is my answer. So the 66.0 is our answer. You might say, well, what's the 0 good for? Well, it's showing that it's at a higher level of accuracy. So we know it's not about 66, we know it's 66.0 degrees. And that's why we need that 0 there. And that would be the angle of inclination is 66 degrees.